Okay, like this one, the left skewed distribution, X bar is smaller than median, and median is smaller than the mode. All right, and conversely, if the distribution is right skewed, like this one, then the mode will be smaller than median and smaller than the mean. Why? Why the mean is the biggest, is the largest? Because it's driven to the right by the extreme values. Okay? We can see from the time. We can see from the figure that the mean value is driven to the right because it is likely that extreme values from the distribution might occur and then drives the mean value to the right. But the median is robust, very stable against the extreme value. All right. And okay, so we already knew that a median split the distribution into two equal halves. Can we divide the distribution into 4 equal quarters? And the answer is yes. And we know how, we already knew how to split the distribution into 4 equal quarters, right? And we have a 3 quartile. Hey, it is called quartile. Okay, QJ called the J quartile. J can be 1, 2, or 3. Understand? And it split the distribution into 4 equal quarters. All right? And we know that the interval from Q1 to Q3 is the interquartile range. Okay, let us look at the example. Traffic violations in 10-day periods. Okay, that's the 10 days traffic, the number of occurrence of traffic violations in 10-day observations. Okay, the first day, 22 cases. Second day, 19 cases. Okay, all the way to 20. And then we first rank them into an ascending order, into this way, from 9, 12, 15, all the way to 25. In this case, n is the number of observation. In this case, it is 10. And Q1, let us, this is Q2, sorry. This is Q2. Q2 is the second quartile. Second quartile is trivially the same as the median, because left to the second quartile, we have 50% of the data. Left to Q2, here. Left to Q2. Left to Q2, we have 15% of the data. And right to the Q2, we have also 50%. So this Q2 is exactly the same as the median, which split the data into 2 equal halves. Okay, 50-50 on the right and left. Okay. So let me make a correction. This is Q2, not Q1. Here, it is Q2. All right. So we calculate Q2 first. Okay. And the number of observation is 10, which is a even, which is an even number. An even number, for an even number, the median or equivalently Q2, okay, is the average of the fifth one and the sixth one. Okay, so we use the average of the fifth one and the sixth one because 10 is the even number, and divided by 2. So it is 18.5. This is the median, or equivalently, the second quartile, Q2. Okay? And what is Q1? Q1, hey, because you already have Q2 splitting the data into 2 equal half. So we have 5 observations right to the Q2 and 5 right left to Q2 and 5 right to Q2. So what is Q1? Q1 is also the median of the first half, and Q3 is also the median of the second half. Okay, so what is Q1? Q1 is the median of the first 50% of the data. Median first 50% of the data. And Q3 is the median of the second. Okay, so they are 15 and then 22. Okay. So 50-50. Okay. And it split the data into 50, 25%, and 75. And this one is split the data into 50% and 25% on the left. And on the right. Okay? Left and right. All right? So now we have a 3 quartile. Hey, always do the second quartile, Q2. It's more convenient for you to do. Okay, first the Q2 and then you split the data into 2 equal half. Okay, the first half, the second half. And for the first half, you calculate, you find the median of the first 50. Then the median will be the first quartile. So it is Q1. And the median of the second 50 is the third quartile. And the third quartile split the data into 50% and 25%. Okay? So what's next? So, but what about Wow. Okay. And what if we wanted to split the data into into a P and 1 minus P. Let me use pi. Okay. And 1 minus pi. For any pi in 0 and 1. Okay. For example, P20, P63, which split the data into 63% and 37%. Okay? Okay. So please go to page 162 for 3 steps that serve this purpose. No wonder the first thing to do is to sort the data from low to high into an ascending order, okay, from low to high. And second, calculate the value of C, and where C is n times pi divided by 100. Um, Let me use a different way to express the formula. Okay? All right, and this is pi. And pi is 63. And p pi all right? Okay, look at this. Okay, we saw in the previous slides, we use Q2 to split the data into two equal half, 50-50. And then we use Q1 to split the data into 25 and 75. And we use Q3 to divide the data into 74%, 75% and 25%. Okay, but what happened? What happened to the box, to the block? Hey. What happened? Okay. So, but what if we wanted to divide the data into 63% and then and on the right 37%? Any number between 100 and 0. Okay, in this case it is 63, and this number is denoted by P sub 63. Okay, and for this purpose, if we wanted to find a number, find a position or location that split the data into 63 and 70 and 30, 63 and 37%, we needed 3 steps to find it. First one, no wonder, sorting the data from low to high. Okay, and then calculate C equal pi, in this case, in this example, 10 times 63. Okay, for example, in this example, pi is 63 and n is 10, then C equal 10 times 63 and divided by, oh no, this is not, right? 63? No decimal. It is 63 here. Just 63. All right. Yep. It is 63 times 10 and divided by 100. So it is 6.3. Okay. So we have the number C, 6.3. And if C is an integer, okay, then P63 is equal to the Cth observation and the C plus 1th observation. Okay, and then divided by 2. So for example, this is 6, right? For example, hey, imagine there is an example, and C in this case it is 6. So C is an integer, so we average the 6th one and the 7th one, and then divided by 2, the average of the 6th and the 7th. Okay, but in this case it is not an integer, and it is 60 and 6.3, right? So which one? What is the smallest integer bigger than this? It's 7. Okay, the next integer, 7. So if C is not an integer, so P63 is equal to x7. Okay, where C prime is the smallest integer bigger than C. Okay, for example, in this case, C is 6.3. So the next one, the next one is the 7th. Okay, the 7th. And the 7th, 7 is the smallest integer bigger than this. So it is 7. The 7th, okay. So let us go back to the example. Go back to the example. Okay. Please go back to the example 3-30. Okay. If pi is 63, if pi is 63, then 63 is equal to the 7th observation. The smallest integer bigger than C. Okay. Okay, back to example 3-30. Okay, and we have an interpretation. Okay, for this example of P36. Okay. Um. P36 is the 63rd among 100. Then is equivalent to then the 7th is equivalent to ranks among 10. All right. Okay. The 63rd among 100 numbers is equivalent to the 7th that rank among 10 numbers, all right? So, and we code P63, the 63rd percentile of the data. Okay? And a 63 can be replaced by any number. In all the way to 99. Okay? Okay, now let me use a plot to visualize. So what is P63? P63 is this. Is the number that is, it is 63% on the left. Right to P63 and 37 right to 63% on the left and 37% on the right. That divided the distribution into the distribution percent. Okay? But if there is only 10 observation, 10 numbers, we take the 7th number, okay, as the as P63. Okay? In this example, roughly, not exactly. You can only say roughly, not exactly. All right? Okay? And now we are closing chapter 3. We are closing chapter 3 after we finish the next subsection. Okay? So please go to section subsection 3.5. Okay. Interquartile. More about interquartile. What? What? Chapter 3.5 is it? Or 2.5? 2.5. Sorry. 2.5. Let me check. No 2.5? Oh. Oh, 3.3. Sorry. 3.3. Hey. Please recall that in last week we introduced RQR, which is the difference between Q3 and Q1. Okay, so what is the big deal? What is the big deal about interquartile range? Okay, I think we have 3 point to see to look at the interquartile range. Q1, the interval Q1 between Q1 and Q3. Number one, the interval. That contain the midmost, the most middle, means the most 50% of the data. Okay. Number 2. Um, bigger value. Of the bigger value, bigger IQR values. Bigger IQR implies bigger dispersion of data set. Okay? Bigger and vice versa. Okay? Okay? And number 3, as a measure of dispersion or variation. Okay? Is robust against extreme values. Not influenced by extreme values. Okay? Okay, 10-minute break. 10-minute break. Yep. You were here? Both roll call or just one roll call? The last one? The date? The date.
I cannot like log into iClass.
12? To the assistant, not for me. For the assistant. Dear assistant.
OK OK，那个系统问题。
Later. What is your name? And seat number? The earlier part or the later part? Or the middle part? No, no, no. Former part of the class or a later part of the class?
Oh, the early one, the first one.
First one? I mean, your number, seat number, is in the former part or the later part of the class. I mean, your seat number, the earlier part, former part, or the later part. Where? Where did you stand? Your. What is your name? Okay. What?
那个我的921这个，我那天手机点不到，就我下课的时候
That's too long ago. Sorry.
它是系统的问题，我点了，可是它没有显示。
12 o'clock. I need a break. Hello? The 3 points are going to appear in your midterm exam. And I will set up the time of our midterm exam on the iClass. So please stay tuned. Stay tuned. Okay? About the iClass. Okay? Please stay tuned. I will set up through the iClass about our midterm, and I'm going to. I think you will going to take the exam after 6 o'clock p.m. No, not yet. And okay, p.m. Please take it. I'm using the camera webcam so that I can look at every one of you to see if you discuss. You can open the book, the notebook or something, but you cannot discuss. Okay? And no mobile phone. I'm going to look at you through the webcam. So please turn on your webcam when you are taking the exam. And you take the exam alone. I want to see you through the webcam that there's only one you sitting on the in front of the table. Okay? In front of your desk. And what is this? The midmost 50% of the data. All right? Okay. So if we know how to that's the benefit. Hey, you can say this is the benefit. These are the benefits of using Q1, Q2, Q3. So that's what we learn from the three numbers, Q1, Q2, and Q3. Is there any other thing we can learn from the three numbers, Q1, Q2, Q3? Is there any other benefit? Anything more than that? Then the three things, the answer is yes. And the answer is in the, which is subsection. Oh, 3.4. Please go to subsection 3-4. We are closing this chapter 3. Okay. by this subsection. After this, we are closing chapter 3, okay? In this subsection, we will introduce a box plot only, okay? So please go to example 3-37. 10 selected states in the United States of America has respectively, okay? 10 numbers, metro cities, okay? Metro city, for example, the first states has 89 metro cities, and the second states has 47 metro cities. Metro city means big city, metropolitan city, okay? Big city, okay? Or maybe densely populated, okay? And construct a box plot. What is the box plot? We will see later. For the data, okay, solution. Number one thing to always keep in mind that the number one thing to do is to sort them from low to high into an ascending order, okay? So just sort this number, okay? This number. I forgot to make a roll call today, the first hour. So we will make for the first time later, maybe later. I forgot. Please remind me from next week if I forget to make a roll call. Okay. So sort them into an ascending order from low to high. That's the sorted data, okay? From low to high, 30, 39, 47, all the way up to 296, okay? And to calculate the median, which is the second quartile, Q2, and also Q1, and also Q3, okay? This is 30, the minimal observation of X. The minimal number of metropolitan city, okay? The maximum number, okay, of the metropolitan city. So what is Q2? Q2 is the median. And the number of observation is 10. In this example, hey, so what is the median of this 10 data set? Hey, remember, observe that the number of observation is 10, which is an even number. So the median value is the average of the 51 and the 61. Understand? So we take the average of the 51 and the 61. So it is the average of 78 and 89 divided by 2. So it is 83.5. Okay, and 83.5 split the data into 2 equal halves, 5 on its left and 5 on its right. Okay, so what is Q1? Q1 is the median of the first half, first 5, and the Q3 is the median of the second 5 numbers. So Q1 is the median of the 5 numbers, so it is 47. The Q3 is the median of the second 5, so it is 164. Okay, 164. Okay, and besides, apart from the Q1, Q2, Q3, we need another 2 numbers to construct the box plot. What are the remaining 2 numbers? The remaining 2 numbers is the minimum one and the maximum one. Okay, the minimum one and the maximum one. Okay, which is 30 and 296. All right. So so we have 5 numbers, and the 5 numbers summary can summarize the whole distribution. Look at this. So The box plot is constructed already in the slide. Okay. So that's the box plot. Box stands in the middle. Okay, from Q1 and Q3. So what is the interval? What is the big deal about the interval? Hey, raise your hand if you want to have some extra bonus. What is the interval? What is the big deal about the interval from Q1 to Q3? Hey, raise your hand if you know the answer for extra bonus. What is the big deal about Q1 to Q3? What? 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 Limit? No. That's not what I wanted to hear. Yep. What? Interquartile range. Not close. It's better, but not close. The interval that contains the midmost 50% of the data. That's what I wanted to hear, okay? Hey, here, it's here. It's still here. I forgot to wipe it off. It's going to appear in your midterm exam. The interval. Q1 and Q3 contains the midmost 50% of the data. Okay? And number 1 and number 2, the red horizontal line are called the whisker. Hey, raise your hand if you are raising a if you are raising a cat or a dog. Raise your hand. Cat or dog? No. The whisker means, you know, and these things, these two horizontal lines look like whisker. Okay, that spread from upper part of your mouth. That's a whisker. It looks like whisker. A cat whisker. That, hey, this is called whisker, okay? Yep. So the box plot summarizes the distribution of a data set. Okay, let me put it. And hey, if I ask you a question in the midterm exam, what is the big deal about a box plot? What is the big deal about a box plot? It summarizes. You should say it summarizes the distribution of a data set using 5 numbers: Q1, Q2, Q3, and the minimal one and the maximal one. Understand? It summarizes the distribution, okay, of a data set. Hey, people make a pen to write things, right? People make clothes to wear, and people make hat or helmet to protect your brand. Okay, so things are invented or created for some purpose, at least for one purpose, right? All right. So people construct a box plot for what purpose? For what purpose? To summarize the distribution of a data set. So a box plot is constructed to summarize the distribution of a data set. Okay, using only 5 numbers. X1, Q1, Q2, Q3, and Xn, the maximal one. All right. Okay. In the exam, I will ask you some question. Okay. With the box plot. Okay, I will ask you what is the value of IQR. IQR, hey, if you wanted to construct a box plot, always determine where the median locates, okay? So first the median, and then Q3, and then Q1, and then X1, and then X10, the maximum number, okay? After you determine the location of these numbers, and draw a box between Q1 and Q3, okay? And draw a vertical bar at the median. So here we have 25% of the data, and here we have 25% of the data. Is going to appear in your midterm. I will ask you how many percent is the left part of the box. So you should say 25, and you should say 25 here. And so is this. So is this. It is also 25 here, and also 25% here. Okay? Understand? And the IQR is the difference between Q1 and Q3. Okay? So the last point to make about the box plot is the outlier. Hey, outlier. If you have data set cluster around each other, okay, and somewhere far from the cluster, somewhere from it, this one, in English, it is called outliers, outlier. Far away from the clustered data. On the left. And we call it outlier. Or call them, if there are more than one outliers, call it outlier, okay? And in Chinese, it is called 离群值, okay? Okay. So, is there any outlier in the data set? How would you reply? Is there any outlier in the data set? It depends. Okay. So we have to specify two limits. One limit on the right and one limit on the left. Any number beyond the limit is called outlier. Okay? So what is the left limit? A left limit is Q1. Hey, if you have Q1, Q2, Q3, the left limit is Q1 minus 1.5 IQR, which is negative minus 145.5. And the right limit is Q3 plus 1.5 IQR, all right, which is 339.5. So any number lie beyond the two limits is called an outlier, okay? And this is the left limit. This is called the left limit. And this is called the right limit. All right. Number 3, any number that lying outside the two limits minus 145.5 and 339.5 is called an outlier. any number. Lying outside the two limits. Yep. 1.5. That's a rule of thumb. The rule of thumb. No theory, just the best practice. Okay. Is called an outlier. All right. Yeah, you ask a very good question. Why 1.5? Why not 2.5? Why not 3? I only can answer you that's a rule of thumb. Okay? Okay, the most appropriate choice in practice. Most suitable. Multiple. In practice. Okay? 1.5. Okay? So in this example, no outlier. Okay? There is no outlier. We see no outlier. Okay? Yep. What? 47? Not 47. So what is it? Oh, no, that's X1. X1, the minimal observation. Q1 is here. And this is the minimal observation. Minimal 30. 30 is the minimal observation. And 296 is the maximum observation in the data set. Okay? In the 10 numbers. So what is your question? Oh, sorry. Oh, thank you. Good. Good. Yep, this is Q1. The Q1 here should be 47. And so what is the number? Negative, minus. Minus 128.5. Okay. Yep. What? Yeah. Red limit. Yep. That's the red limit. Oh, red limit. Oh, sorry. Wrong direction. Wrong direction. This is the right limit and this is the left limit. Okay? Good. You two guys can have extra bonus. Okay? No extra bonus? Oh, here. What is your name? Seat number? Number 2? Good. Where is it? Hey? Where there's nothing. Extra bonus, nothing. Okay? Oh. 1%. Hey? How can I do the extra? Hey, what happened? Why can I not? Hey? What's wrong? Oh. Number 2? Yep. And are you? Hey. What is your name? What is your name? Huh? No, I didn't see it. Liao Jiayu. Where are you? Hey, what is your name? Where is your seat number? 12. But I cannot find your name. What? This one? Liao Jiayu. Okay. Hey? Why did it disappear? Ah, where is it again? Ha. Yeah, you already have it. Okay. So, like I said, I said a box plot can summarize the the distribution of a data set. Hey, in a midterm exam, okay, if I give you the box plot, you have to select. You have to select. Okay, one of the 4 distribution that correspond to the box plot. Okay, and hey, look at this. Like I said in a previous slide, this is 25%, and so is this. Okay, so in a short interval, it contains 25% of the data. So the distribution should be very high frequency. Okay, and in the second quarter, it is also 25 in a short range, in a short interval. So the frequency should be high, such that it is also 25. But here, the interval is bigger. It also contains 25, so the frequency should not be so high. Should be lower. Okay, so it should be lower. And here, much lower, more lower. Okay, And because the interval is so long and it also contains only 25, so the frequency should be low. So here we can tell from the box plot that the true distribution should be right skewed. Okay, it is not this one, neither this one, and not this one either. Okay, this is bimodal, okay? Okay, not symmetric, not bimodal, not left skewed. Hey, in the exam, you should choose this one. Okay, we can tell the shape of the distribution from a box plot. So we can tell the shape of a data set from a box plot. From the box plot, not A, because there's only one box plot. So here we should use the box plot or its box plot. Okay? It's going to appear in your midterm exam. Understand? Okay. Second roll call. First roll call, sorry. Don't pass the code to the absent student because you have only 8 seconds this time. It's getting shorter. All right? 1 minute, 1 second, 2 second, 3 second, 4, 5, 6, 7. I think it's 10. Not anymore. I will do it manually if you come to me if you can make it. So we just end up the third chapter 3, and we're going to look at chapter 4 next week. Okay? And your assignment this week, please point out the benefit of using IQR. That's the benefit of using IQR. You just make a copy. Use handwriting on the paper. That copy this part. And also, that's the big deal about Q1, Q2, and Q3. And what is the big deal about a box plot? Okay? The big deal about a box plot is that it point out the interval that contains the midmost 15% of the data. And the red horizontal lines are called whisker. And any number lying outside the two limits, okay, is called an outlier. I will fix this, okay? Okay, so what is the big deal about box plot? A box plot is constructed to summarize the distribution of a data set using only 5 numbers, all right? All right? Hey, in the I class, you will see two files, one for the for one for the chapter 3 and one for the chapter 4, okay? And chapter 4 is to be used the next week. Okay, too late to use it now because we are, we're having a lunch. So go home and write the 2 slides. Make a copy of the 2 slides I just mentioned as your assignment and do an exercise. Please do an exercise here. I want you to construct a box plot yourself. Here. Box plot. Please go to page 188. 188. Exercise 28. Exercise 28. Okay. Exercise 28 and 2 slides and exercise 28, page 188, and 2 slides. One IQR, one box plot. Okay, so that's the homework for this week. Hey, don't shoot me. Don't shoot me.